G'day YouTube, Warbles on a lot here. Welcome to load test number 3 of the great battery rescue resuscitation saga, this time with specific gravity. However, we'll start off with a bit of a bad news, good news, bad news scenario. On the bad news side, we're going to have some cloud in today's sky. On the good news side, battery combination CD, which 2 days ago after 30 amp hours was resting at 12.88 volts in the morning, and yesterday after 36 amp hours it was resting at 12.93 volts in the morning. This morning was resting at 12.96 volts, while battery combination E and F, which 2 days ago after 36 amp hours was resting on 12.92 volts in the morning, yesterday after 42 amp hours was resting on 12.98 volts in the morning, was today after 50 amp hours resting at 13.01 volts. So there you go. What do you know? Battery that's only taken 28 days to get here if treated with kid gloves, and if you know what you're doing, can be pretty much resurrected and brought up close to showing the kind of voltage that it should be showing. So I haven't actually written down or measured and written down the specific gravity of the electrolyte in these 4 units because I haven't seen much of a need, on the grounds that the batteries are performing appropriately according to the diet of current that I've fed into them and the amount of time that they spent getting here, based on a sulfation rate of 0.9% self-discharge of the stored charge per day. 22.5% down, so they took 28 days to get here. Whereas the combination A and B, which were respectively 40% and 42% discharged, so at a sulfation rate of 0.9% a day, they took 57 and 61 days to get here. 2 days ago, when I'd pumped 178.007 amp hours into a 225 amp hour storage battery, they were showing 12.77 volts. Then I sucked 22 amp hours out of them and I replaced 23.939 amp hours, and then yesterday morning, when they had 179.43 amp hours gone in, because I'd replaced the 22.5 amp hours that I pulled out, yesterday morning they were resting at 12.82 volts, and I thought, yeah, well, okay, that's pretty good. However, under load after 1 hour, they were reading 13 amps drain at 12.295 volts 2 days ago. Yesterday, after 1 hour, they were reading minus 13.6 amps, so a bit more current, but 12.265 volts. So, yeah, the volts were down 0.03 of a volt, and the amps were up 0.5 of an amp. I think I worked out that they were actually delivering forth 3 watts of extra power after the first load test recharge cycle. And then yesterday I took 14 amp hours out and I put 27.862 amp hours back in. So this morning they were sitting on a total of 191.82 amp hours being pumped back in to a 225 amp hour battery, and they were still resting at 12.82 volts, same as they were yesterday. Because I've had breakfast, mucked around and insisted on starting to make the video between setting this thing up and actually starting the load test, they're now showing 12.8 volts. Occasionally it flickers back up to 12.1 volts. I'm pretty sure that's the transient drain caused by having the inverter connected. So there is a circuit with a little tiny bit of current leakage in it. And as I mentioned in the introduction, today we have a little bit of a look at the specific gravity. Oh, sit there. Bugger it, fall over then. This, for those of you who are unfamiliar with the device, is called a hydrometer. Basically, there's some lead shot in a little sealed float. It's very carefully balanced, and the idea is that if you've got pure water in there, it'll float at the level of the top of the red scale. Pure water has a specific gravity of 1.000. Battery acid has a specific gravity of 1.3, 30% more dense because of all the sulfuric acid dissolved into it. And you've got a green zone, a white zone, and a red zone. And because battery acid is corrosive, this is my, not patented, but by gee, it's a good idea, container for the hydrometer so that it can drip its battery acid, which can then be contained. You've got less chance of having it spill on your pants. So this is the instrument with which we measure how much electricity is being stored in the battery juice, in the proverbial layman's terms. Here on the graph we see water with a specific gravity of 1.000, and we move up the scale to 1.3, which is pure battery acid. And when you've got an electrolyte specific gravity of 1.3, the battery is 100% charged, and its voltage is 13.2 volts because it's 2.2 volts per cell. When I first started going to the dump, getting throwaway batteries and bringing them home and trying to resuscitate them, I rapidly learnt from several textbooks that it's a good idea to go and check the voltage, but just don't believe it, because lots of batteries show a suspiciously high voltage. You know, up around the 12.5 volts, maybe even 12.8 volts, which would indicate that they are 75 to 90%, or 75 to 87% fully charged. And you'd think, why would somebody throw them away? The point is, if you go and get those batteries and have a look at their specific gravity, quite often it'll be down there around the 1.2. And that means that the sulfuric acid is no longer in solution in the battery. The water has boiled away and been replaced with more, hopefully, distilled water. And the sulfuric acid, or the hydrogen ions therefrom, they have formed lead sulfate, which has been thermally shocked off the battery plate and fallen down into the sludge trap. So even if you have got reasonably bare lead plates in there from all the thermal shocking that's going on, you haven't got the electricity stored in the solution because it's all become lead sulfate crystals at the bottom of the battery. So you dump battery that's got a really good voltage and a really horrible specific gravity. As soon as you give it a load, it just goes zip, bang, back down to show your 11.5 volts with your 1.120, and that means 40% charged, and that's why the battery was at the dump. So I checked these A and B batteries this morning. It's a singularly uncinematographic procedure. What it means is that right across the board, all three cells, battery A is running 1.275, 1.275, 1.275, and battery B, it's running 1.275, 1.275, 1.274, and it's running 1.274 on its positive terminal. So that's the cell there that's got a specific gravity discrepancy of 0.001, which is 3 parts of 2/10 of 5/32 of sweet fanny atoms, to put it in the polite vernacular. Not worth worrying about. What this does mean, with a specific gravity of 1.275, where's my end of the finger there, 1.275, what we're looking at is theoretically a 92% charged battery. Yet, however, with 12.81 volts, the volts suggests that it's resting 87.5%. There's a pretty big difference, the discrepancy between what the specific gravity is and what it should be for that voltage. And then as soon as we throw a load on it, well, it drops down here to the 1.265, 1.295 area, which is 67.5%. So there is a vast discrepancy between the voltage and the percent charge that it shows under load and what it should be performing like according to the specific gravity of the electrolyte. And what that means is that the sulfuric acid, which is no longer in solution in the electrolyte, it has become permanently affixed to the lead plates, and it is blocking the flow of electrons from the plates to the solution when you try to charge it up. So your voltage goes up before you finish administering a correct recharge. And it means that the electrons can't get from the electrolyte onto the plates to feed the circuit that's sucking on the battery. And that's why the battery is down here holding 12.26 volts under a 6% current drain, when it should be up there around the 92 to 94%. So we really should be showing about 13 volts under load. And it's just not doing it, because it can't, because it's sulphated from self-discharge. Due to the systematic, deliberate lack of being given a maintenance charge during the 61 days that it took to get from the factory to the point of end retail sale, because the battery manufacturer doesn't care how long it lasts, as long as it goes 1 week past the warranty period in a golf cart or a forklift or whatever industrial application it's being normally purchased for. So anyway, now we know what the resting voltage is, we know how much current has gone back in, we know what the specific gravity of the electrolyte is. Let's suck 10 amp hours out and have a go at recharging it. And after we suck the 10 amp hours out, we'll let it sit for half an hour and I'll measure the specific gravity of the electrolyte to convince us that all the cells are providing roughly the same proportion of the current that's being emitted by the two battery combination. So, yeah, it copes with half an amp pretty well. Time check, 10:45 by the way. Right, 13 amps, 12.66. You just keep watching it while I go and find what the hell I've done with my pen. 1.5 minutes and we're down to 12.3 and 13 amps. So current's down, voltage is down. Wish I could figure out what I've done with the pen. Yeah. I'm going to go through with this load test, but I don't think it's going to improve any on this. I think this is as good as these batteries get. So it looks like we're going to find out what Century does when a warranty claim gets made by a mad scientist. Well, it's holding its 12.25 volts moderately well. But 12.25 is not 13. .25 is 35% discharged, when the battery was trying to say that it was 87% charged. So yeah, it reckoned it was 13% discharged and it's actually 35% discharged while resting. And it wouldn't hold the full charge that it got yesterday. Sulfation, the avoidable bane of lead acid battery storage. All you have to do to avoid it is to make sure that every day after the battery has been filled up with its brand new electrolyte, every day it gets a maintenance charge consisting of at least 1% of the rated capacity. So if you've got a 225 amp hour battery, it needs 2.25 amp hours, preferably 2.5 or 3, every day to prevent any of the lead sulfide from ever turning into lead sulfate, so that you've got the entire surface area of all the plates that were built into the battery with which to conduct ion exchange. There we go, 5 minutes, 12.28 at 13. Right, well, I'm going to keep on doing 5-minutely observations on the battery while setting up my washing machine, because if I don't do some washing, I'm not going to have any clean clothes to wear. I will come back to you later on. 10:55 minus 12.95 amps, 12.335 volts, which is a confusing bit of a change. And it's really only when you convert volts times amps into watts that you can see that it's no difference at all. 13 amps and 12.28 volts is 159.6 watts, whereas 12.95 amps and 12.335 volts, that's 159.7 watts. So the difference is 1/3 of 1 watt, which is not enough to bother about, but that's what's happening. It expresses itself as a slightly different voltage and a slightly different amperage because the battery trades amps for volts. Don't know why it trades amps for volts, because like I said, I didn't do chemistry or physics in school. I've just spent a lot of my life trying to get old throwaway batteries to function well enough that I can run my hut without having to pay for new ones. So when I paid for a set of new batteries, I really wasn't expecting to get 2 of them that were as clapped out as this. I pretty much expected the other 4 to be in the condition that they were when they arrived. And yeah, I'm self-confident to the point where I figured I could fix them. These ones I'm not so sure about. Below that, I am sure about it. I'm sure I can't fix them. 11 o'clock, 12.345 amps. And 12.345 volts and 13 amps. 5 past 11, 12.345, 13 amps. 10 past 11, 13.345 volts. Ooh, we got some wibbly wobblies on the amps. 12.9 amps. 11:15, 12.34 volts. 12.9 amps. So at 11 o'clock, I was putting out 160.488 watts, 0.485 watts. 11:05, the same. 10 past 11, 159.2. 15 minutes past 11, 159.18 watts. And we've pulled out 6.4875 amp hours in the first half hour. 20 past 11, 12.33. 12.8 amps, which is 157.824 watts. 11:25, 12.33 volts, 12.7 amps. 11:30, and we got 12.325 volts, and yeah, 12.75 amps, which is 157.14 watts. 11:35. So that's 10 amp hours have come out. 12.315 volts and 12.5 amps. And I'll just turn that off there and let you watch that for a bit. Okay, so the game plan is now for me to let the battery just sit there for about half an hour, perhaps 3/4 of an hour, and then I'll measure the specific gravity and write it down. And during the intervening time, I will start actually doing the washing, because the swamp wallaby has arrived. The water drain has been assembled. and the washing machine is in situ. Okay, 12:05. We've had half an hour to recover. They're showing 12.645 volts. First load of clothes is in the washing machine. And I've decided that because the textbook says you should wait at least 1 hour after discharging, or at least 1 hour after charging in order to get an accurate specific gravity reading, I'm going to wait another half an hour before I start playing with juices. Okay, we're now coming up to the hour since we finished discharging. 10.8 amps. Below that, 10.8 amp hours. Indicating 12.67 volts. So we pop the top on the cells. Okay, so here with the procedure. Drip catcher bottle over there. These little bastards of numbers habitually run away. .255. So we put that back in there. And we write down the reading. You may notice I push the air out of the top bulb before I stick the proboscis into the cell. 1.255. Oopsie. 1.245. So that's where most of the power has been coming from that battery, is the cell under the positive terminal. Right. One point 25. One point 250. 1.255. Right, now let's have a look at the chart. So we've gone from 1.275, which indicates 92% charge, to between 1.245 and 1.255. So I'm just going to arbitrarily call that 1.250, which is down here, 87.5% charge state. So that shows a 4.5% drop in the electrolyte specific gravity, which is a 4.4% drop in the stored charge, or 10 amp hours out of 225 amp hours. Let's be really pedantic. 10.83 divided by 225 equals 4.8% drawdown on the rated capacity of the battery. And we've got a 4.5% drawdown in the specific gravity of the electrolyte. So there is nothing wrong with the electrolyte. Where the source of the wrongness is located is in the plaques of lead sulfate upon the battery plates. And I don't think I can get them off. Not that it's going to stop me from trying. Right, 1250. Panel's connected, but it's face down. And there we go, we are now connected. More or less roughly tracked. .34 amps, 12.79 volts. Oops, get out of the way of the sun. We'll see what that's doing in a couple of minutes' time. I'm a minute early, 12.93, but my son's just showed up. Okay, conversation concluded, and it's 13:22 hours, 13.31 volts, 9.93 amps. Abas 1, 13.47 volts, 9.54 amps. 20 minutes to 2, 13.63 volts, 9.78 amps. 10 to 2, 13.69 volts, 9.51 amps. 2 o'clock, 13.8 volts, 8.56 amps. 5 past 2, 13.75 volts, 6.05 amps. 10 past 2, 13.79 volts, 5.73 amps. Quarter past 4, 14.03 volts at 4.42 amps. 20 past 2, reading 14.09 volts. Where are we? 3.45 amps. Bouncing around a bit there. And as at 5 minutes ago, we'd put in 11.38 amp hours, which is 105.37% of the 10.8 amp hours that I took out this morning. 25 past 2, 14.19 volts, 3.3 amps. 2:30, 14.38 volts, 3.97 amps. 2:35, 14.46 volts, 4.18 amps. 20 to 3, 14.51. Yeah, half a minute ago it was 14.54. And it was showing 4.29. Since I took those readings, a cloud has come before the sun. 2:45, 14.55 volts, 4.17 amps. 10 minutes to 3, 14.49 volts, 3.57 amps. So I make that 2 hours it's been charging. And seeing as in 1 hour's time I want to have a play with the hydrometer, that means it's now time to fold the panel flat and let the electrolyte specific gravity stabilise as the voltage slowly goes down. So in about another hour, we'll see what there is to see. Kind of funny the way the hydrometer decided to jump into the screen. Okay, so it's been an hour since the batteries came off the charge. They're reading 12.96 volts, and that's not as good as those 2 pairs of batteries over there were doing this morning at about 5 degrees Celsius when they hadn't been on the charge since the previous sundown. So anyway, it now becomes time to check the specific gravity once again. Okay. $1.275. 1.26. 1.26. Oh, you stand up. 1.26. 1.26. $1.26. I wonder if that first cell I was reading the markings wrong. Go back and have another look. $1.26. Which actually puts all my readings this morning into doubt. Unless the fact that it's about 15 or 16 degrees Celsius now, the electrolyte has been heated up by being charged, and this morning it was about 5 degrees or so. I mean, overnight out here it would have got down to about 0 degrees, and perhaps the temperature of the electrolyte has a bearing on the density of the electrolyte, which would have a bearing on the specific gravity of the electrolyte. Maybe so and maybe no, and maybe baby, I don't know. What do you think? Hey, what do you think? Little swamp water bubby. Swamp wallaby that's an expert in solar electric battery charging. Swamp wallaby that's going to be a 4th generation expert. Learned all about it in the pouch. You're a good girl. Yes, you are. Yes, you're a very good girl. Yes, you are. Oh, did I sit down? Did I go to talk to your Joey? Hey, can't have that, can we? We don't want the Joey to have a personal conversation with the family's pet tame human. Oh, she says, what are you talking to? Eh? Are you a telepathic swamp wallaby? Are you a telepathic swamp wallaby? Right, let's see what these have been doing. Battery C, 6.79. Battery D, 6.77, which gives us 13.56 with 0.8 of an amp going in. Below that, 0.08 of an amp going in. Battery E, 6.77. Battery F, 6.75, which gives us 13.51 with 0.05 of an amp. So considering that that solar panel puts out about 10-15% more juice than that one does, what I plan on doing is swapping the panels around tomorrow, and either Monday or Tuesday I think these 4 can go into the pyramid, because they were like 22% self-discharged when they arrived, 22.5%, and 45 amp hours is 20% of 225 amp hours, I think. Pretty close anyway. So that's just had its recharge. That's actually had its recharge perfectly, because it's had 10% more than it lost, kind of thing. So yeah, I'll just let them sort of simmer quietly for another 2 days on the little 10 amp panel. See how good they can get. Trickly charging with whatever clouds in the sky to moderate the current going in. And as for this pair, well, we'll see what Mr. Century has to say about the idea of a warranty claim. Failing that, it might be time to start trying a specialised pulse charge machine to try and shock the sulphate off the plates. What else could we try? We could try adding some cadmium sulphate to the electrolyte and see if that can chemically make some changes. What do you think, Felix? Sorry, you're not Felix, you're Clippy. Hey, what do you think, Clippy? Hey, you want to take it from my hand? That's a boy. Hey. Not so many people can say that they've fed a bull male or an alpha male swamp wallaby. But this fella's the ranking male wallaby bicoloratura on this hill anyway. Probably for about a kilometre around. He has got one up and coming challenger, a bloke called Felix. Clippy is the boss. So, that's the battery saga. Illustrating and explaining and illuminating the third load test with electrolyte specific gravity measurements. Oh, I think that'll be about enough for one day's video. Warbles on a lot to YouTube. Ciao.